G'day viewers, I'm after this and repairs on this. This fuse holder is floating around, the nuts came off. I have to fix that. Calibration seal is already half broken. Let's get it all apart, repair that loose bit and have a look inside this thing. This thing is very well built. Still smells okay. Very interesting stuff. SPI Power Net, then it became SPI's Net. Singapore Power Industries, and it became Singapore Power Australia Network. Now it's called Oz Power Networks, which is actually owned by the Chinese government. But yeah, the story with that, SPI's not got into a lot of strife for their bushfire. The bushfire issues and their poorly maintained infrastructure, like power line, power poles going down, that sparked a bushfire. And the Singapore part of it, they heard about it and didn't want anything to do with Australia after that. So, poor management was to blame for that. That has to go on something else in the control board, I think. There's a big control board from this wall to about that Chrysler TV long, and from that back wall to about here long. So it's about at least 3 by 2 metres wide. And they, if I had a truck, and the other guy had a truck, I could have got hold of one of those too. But apparently, they can't, the other technician to get these off works from home. The OH&S guy, he can't do that anymore. He can work from a workshop now. So now they've got to relocate everything. But this workshop and this test bench I was talking about, that these all would have plugged into at one point, and saw that the same test bench is being used from these ones and those ones down there, and that's all been upgraded and modernised. But apparently someone recently lit that test bench on fire in an accident, burnt the test bench up. It's fixable, but the person that owns the workshop, the landlord there, condemned the whole workshop. And now they got to work from home again. So they tell the OH&S guy what the hell's going to do here. So yeah, it's OH&S gets in the way now. So they got no workshop to test the new meters. It's all burnt, and the guy doesn't want to fix it. He wants to condemn it. So it's all just, yeah, unorganised. Anyway, let's get this thing opened up and have a look inside. It's microcomputer run, so I haven't got everything to run it. That pornology, mate. Pornology. Make you cream your pants. There is no nut on that fuse. It just sits in there. Look at that. That's just porn in a box. Bearings are bad. It's a 230 volt fan. Made in Japan. Good quality stuff. MS555. And sort of models, German made capacitors, transformers and stuff in there for resistive loading of the meters. How it's actually powered is by 3-phase, and it plugs into a control board, as I said. The computer parts in there, MS555. There's our switches. Go to those contacts in there. But check that out. They don't have earth in the plug in either to actually use this thing. It'd be nice if I could use this. But the way I've done it there with a variac and everything, it's the same thing anyway. This is just a stricter way to do it on the computer for the long term. Look at that. Smells good in here. Arco brand big resistors. Bloody this stuff here is good shit too. This electrical backing board. Masonite. That one must be a mica sheet, that one. I mean, Australian Solenoid Co. Proprietary Limited. Look at that. That's bloody good quality. Australian made. Look at a tow rod in there, is there? Toroidal transformer or something. Current transformer in there. Look at the quality of it. Man, I can't believe they just throw these things away. But they put so much pride and workmanship into making these things and no one gives a shit. That's just really pissed me off. I think that should come out. The bottom's held on by something. No screw there. Might be a screw on this side. No. What's holding that on? It's bolted to here, okay. I'm going to take those screws out to get this side off. I want to repair that fuse bit. I'll take this side bit off if I look behind here. Custom made. There's all the chips in there. Hey, even these are bloody mica. This sort of stuff's expensive. Oh, it's wood coated with mica. Man, this is really well made stuff. The other one's identical to this one. And the screen's up in there. Which goes 8817 at 1988, a date code on that. That screen's driven by something in there. One of these micro computers runs that screen. I'll take that other side bit off so I can fix that fuse holder and take some covers off. Should have broken these bits here off, so it's been apart before when it's been calibrated in the past. I'll take this board off, have a good look inside. That's just porn, look at that. 35 amp heavy duty switch. 3 phase or 1 phase motors. Crowls and Namia, Australian solenoid. I wonder if it's actually made in Australia. 1988's a date code on all these. That is quality. That's how you make a switch. Nice phantom loading transformer in there. 7th 1988. Pretty sure it's a date code. It's on most of the things in here. Well, I'll take this side bit off. Power switch. Actually, it's a breaker. It's a circuit breaker. Find out how this wiring goes in here. I think it's 3-phase input. Have a good look. Looks like a 3-phase input. I could just plug this thing into my 3-phase power point. Interesting. Everything in here is 1988. 1st of the 8th, 1988. Bit older than I am. There's a bolt down, there's a nut down there, there it is, that goes in the fuse, so I have to screw that back on underneath this. So we've got black, red, white and black for that transformer. It's a 3-phase transformer. That is nice. That is nice. Powers that. So the whole unit's powered by 3-phase. 30 amp breaker on it. May be able to power this thing up. Okay, that's interesting. Where do the meters go in? Interesting. Optical sensor, which picks up the turns of the disc. Keyboard programming this thing, I think. And it also does a solid state Nielsen meter. This might be through one of these somewhere, the pulses or something. Part of what that would do too. I might be able to power this thing up. I think I found out how to use this thing out, viewers. Keyboard, this is your keyboard. This is what I was talking about. This is for your computer. Now I have to select what the meter specs are of one thing in the computer for something to do with the voltage. Set it, this goes in here. This is a keyboard here. This is called a keyboard. Plugs in there. Right, now I get it. But the optical sensor are missing. So this thing actually goes on the premises at the switchboard of a house. So what you do, you unscrew your active, neutral, and I think your load. Yeah, neutral, active, and your load have to undo. So your neutral, active, and your load. And you place those screws with these connectors. And that's done with this screwdriver. They screw into the terminal screw holes of those terminal block of those meters. Then you plug the 3 of these into it. They plug into there, turn the supply on, and this is just a resistive load box for the meter. So that's what it is. So I could run this thing. So it's not 3-phase powered. So following these instructions, I can has all the instructions here how to use this thing. So I don't have this blue book. The safety requirements of the blue book must be observed at all times. Very interesting. There's a bit of mathematical bits and pieces involved here. So calculate the percentage error. This is how to work out the error. So this should give me what the meter requires, or this thing here tells me a base reference, and I can use just mathematical equation to determine the error of the meter for proper reliable accuracy. Coupled to okay. It even does direct connected polyphase meters, so 2-phase SD. I can do the SDs of this one as well. The bolts are all falling out. to test Nelson EMS 2100 digital meters. Okay, so this might be here. To perform dial test, select dial for menu, select 38 range or maximum rating of the meter, whichever is the least. Run meter for 1 kilowatt hour and compare with test set reading. Yes, okay. Test counter. Count 10 decimal revolutions test duration, typically 30 to 90 seconds. Meter error will be displayed on test set at conclusion of the test. Use percentage switch to select appropriate current levels. So this one. And it should be on this screen what the error is, and that will give you all of what you need to mathematically calculate the error percentage of what the meter should be. I'm pretty sure that's what this unit would do. Very interesting stuff. It works. It's even got a brightness adjustment for this LCD. Viewing angle, you turn the brightness up, menu. Well, I selected the volts, enter. That's my voltage. How do I get out of that? Now I've got to find out it's all connected right. That's how it connects. Yep. Look at that, it works. Brilliant. Breaker on. Turn the light of the meter off. Beautiful, it works. Oh, it gets out of the menu with that one. Scroll menu key to select test. Menu. Voltmeter, I've done that. Enter. Meter error. Reds per kilowatt hour has been selected. And it's ready. I think we're ready to go. Now it's going. 15 amps. 25 amps. Full load. Because it's not pulling much, see? How good's that? That's the supply I'm using, and that's what it's putting out. I'm fully loading that meter. That's a good phantom tester. Ready. Let's find out how to use this bit. It works. I've got to find out how to use this computer part, so I can actually run the meter as it specifies and actually do a test. But that's how you connect it. How good's that? This baby works. And I can turn the meter off by flicking this button with a breaker. That's a better way to do phantom load test for my meters. Load switch in off position. Turn the thing down. Out of that. Meter error, dial, enter that. Switch to 100% load. Okay. Done that. Kilowatt hours ready. I've got to read the instructions, but it tells you in here what you're going to do, so I've probably got to read the kilowatt hours. So this I did a test, and I've got to read what to put in there, set the test, look at the meter, do the calculations and time it, then it's got the mathematical equation what the error should be. Pretty sure that's how this thing actually works. So, other menus. You've got menu, we've got voltmeter, meter error reading, dial, and that's it. So there's 3 things I can choose from. What are these for? I don't know. Maybe for a scope or something. Optical sensor, I think. That goes onto a little thing here to pick up the things on a disc, or possibly the infrared part of the Nelson meters that have this infrared sensor here, the transmitter. I reckon that's what that optical sensor bit's for. But it works. So this is the big bulky transformer in there for, to step up the current to load the meter up without pulling much on the mains. It's pretty much what I'm doing with a variac mont and the potential transformer. It's the same thing with all in a box. I like I use this. It's more convenient and I can put it away, it's less messier. This is more professional. Beautiful. Anyway, that'll be enough for now. Thanks for watching.